Exercise 6.4. Let's have question number 1. Let ABC is similar to DEF and their areas with respect to the 64 square centimeter and 121 square centimeter. If EF is equal to 15.4 centimeter, find BC. So we have two triangles which are similar to each other, ABC and DEF. Let's have these two triangles. This is ABC, DEF. These are similar triangles. Their areas are 64 square centimeter and 121. The area of this triangle is 64 square centimeter, and here you have 121 square centimeter. If EF is equal to 15.4, EF is 15.4 centimeter. Now you need to find BC. You're going to find BC. So this is your question. So write down given triangle ABC is similar to triangle DEF. Where area of ABC is equal to 64 square centimeter, area of DEF is equal to 121 square centimeter, and EF is equal to 15.4 centimeter. Got that one? Sorry, we need to find. To find you need to find BC, length of BC. Solution. Since triangle ABC is similar to a triangle DEF, this is given. ABC is similar to DEF. ABC is similar to DEF. Now after that, which implies that, now we proved in theorem 6.6 that if two triangles are similar, their ratio of their areas is equal to the ratio of their the square of the ratio of their corresponding sides. So I can say, which implies that area of ABC divided by area of DEF is equal to any corresponding side, the ratio of the square of any corresponding sides, the ratio of the square of any corresponding side. So I take BC by EF, then whole square. So reason is from 6.6. Or you can say a ratio of area in similarity. So you go, which implies that I know area of ABC, that's 64 square centimeters, so it's 64 divided by area of DEF, that is 121, is equal to BC, I don't know, divided by EF is 15.4, then I have square, then I can write 8 by 11 square is equal to BC by 15.4 whole square. Then I'll Give square root to both sides. So what I'll get? Now cancelling square and square, since it's a distance everywhere, distance cannot be negative. So BC and this is distance is not negative. So cancelling square means I'm giving square root to both sides and I'm considering the positive value since it's a distance here. So cancelling squares, what I get? 8 by 11 is equal to BC by 15.4, which implies that, so you got BC as 8 times 15.4 divided by 11. Therefore, BC is equal to, now you can solve this. Now let me solve this on calculators. So I have 8 times 15.4 divided by 11, so I have 11.2 centimeter, and that's your answer. You make a note. Then we have question number 2. It says diagonals of a trapezium ABCD with AB parallel to DC. I have a trapezium. Trapezium A, B, C, D, where AB is parallel to DC, intersect each other at point O. The diagonals of this trapezium intersect at point O. If AB is equal to twice CD, AB is twice CD. Got it? Find the ratio of areas of triangles AOB and COD. AOB and COD. We need to find the ratios of areas of these two triangles. So, what is given? A trapezium ABCD in which AB parallel to DC and AB is equal to twice CD. This is given. To find, you need to find the ratios of areas of these two triangles. So we have area of AOB. Area of AOB is to area of COD. This is what you are going to find. Let us consider these two triangles. Consider triangle AOB and triangle COD. AOB and COD. Since angle AOB is equal to angle COD, yes, why? Vertically opposite angles. Vertically opposite angles. Then I can say angle OAB, this angle OAB is equal to this angle. Since AB is parallel to DC, these are alternate interior angles, is equal to OCD. Alternate interior angles for AB is parallel to DC. You got the reason? Therefore, what I can say? Therefore, triangle AOB is similar to triangle COD by angle-angle similarity criterion. Got it? Then I can say area of AOB divided by area of COD is equal to AB by CD whole square, again by theorem 6.6. So I can say ratio of area under similarity. Got it? Which implies that area of AOB divided by area of COD is equal to AB is nothing but twice CD. So I'll write twice CD divided by CD whole square. Got it? Now CD gets cancelled, so I have 2 by 1 whole square. That will give you 4 by 1. You got it? 4 by 1. Because 2 2's 4. Therefore, area of AOB is to area of COD is equal to 4 is to 1, and that's your answer. That's the required ratio. You got it? Now let's have question number 3. In figure, we have a figure. This is a figure A, B, C, D. ABC and DBC are two triangles on the same base. ABC and DBC are on the same base BC. If AD intersects BC at O, AD intersects BC at O, like this. Show that, you need to show this thing. See, given pay attention, this is a very important question. What I'll do, triangle, given is triangle ABC and triangle DBC share a common base BC. Share a common base BC. And share a common base BC. Then you can write BC and AD. BC and AD intersect at O. What we are going to do? We are going to do area of ABC divided by area of DBC is equal to AO by DO. AO by DO. This is what we need to prove. Let us do the construction. Let me just draw the perpendicular from A to BC and from D to BC again. Name this M. So what I'll write, draw AM and DN perpendiculars to BC. Okay. Let us have the proof. Let me find the area of triangle ABC. Since area of ABC is nothing but 1 by 2 times base, take base BC, times corresponding altitude is AM. Got it? This is area of ABC. And area of DBC is nothing but 1 by 2 times same base BC, because we are given that they share common base, times corresponding altitude is DN. Now let us find the ratio, which implies that area of ABC divided by area of DBC is equal to 1 by 2, 1 by 2 goes, BC gets cancelled because we are doing the division. BC gets cancelled, then we are left with AM by DN. Let us call this as equation 1. Now consider this small triangle and this small triangle. Now consider triangle AMO and triangle DNO. Since angle AMO is equal to angle DNO, each 90 degrees. Also we have angle AOM is equal to angle DOM, vertically opposite angles. Therefore I can say triangle AMO is similar to triangle DNO by angle similarity criterion, then if triangles are similar, then what I can say, then AO by TO. AO, now take the corresponding sides, AO by TO, AO by DO is nothing but AM by DN. Isn't it? This is CP ST. Corresponding parts of similar triangle. Now let us call this as equation second. Now compare first and second. Comparing first and second. Therefore, now when you compare first and second, you see AM by DN in both sides. So the left side is also equal. Therefore, area of ABC divided by area of DBC is equal to AO by DO. This proves our result. ABC divided by DBC is equal to AO by DO. Hence, proved. Call that down. Strengthen. Make a note. Now question number 4, again an important one. It says if the areas of two similar triangles are equal, then prove that they are congruent. So we have two similar triangles. Let us say ABC and XYZ. It says these are two similar triangles and their area is equal. So what is given? Triangle ABC is similar to triangle XYZ, where area of ABC is equal to area of XYZ. To prove, we are going to prove these two similar triangles are congruent. Triangle ABC is congruent to triangle XYZ. Proof. Since area of ABC, since triangle ABC is similar to triangle ABC is similar to triangle XYZ, it is given, which implies that, then you know from theorem 6.6, if triangles are similar, the ratio of the areas of these triangles is equal to the sum of the ratio of the sides, corresponding sides. So which implies that area of ABC divided by area of XYZ, it is equal to, let us take one side, say AB by XY whole square. You got it? Or you can say AC by XZ whole square. Or you can say BC by YZ whole square. Now the reason is ratio of area under similarity. Ratio of area under similarity. Now, which implies that what I got here, C, which implies that area of ABC divided by XYZ. Now, area of XYZ is equal to area of ABC. So, I'll write area of ABC is equal to what? AB by XY whole square is equal to AC by YZ whole square is equal to BC by YZ whole square. Now, this is nothing but 1 is equal to AB by XZ whole square is equal to AC by XZ whole square is equal to BC by YZ whole square. Got that? Now what I'll do, these are all distances, so giving square root throughout. What I'll get? I'll get square root of 1 is equal to AB by whole square, give the square root is equal to square root of AC by XZ whole square is equal to square root of BC by YZ whole square. What I did? I gave square root throughout. Considering the positive value, why? Because these are all distances, which implies that what I'll get, square root goes, square root goes, square root goes, so I'll get 1 is equal to AB by XY is equal to AC by XZ is equal to BC by YZ. You got it? So these are all equal to 1. Then I can say AB by XY is equal to 1. I can say AC by XZ is equal to 1. I can say BC by YZ is equal to 1. Now if you see, AB by XY is 1, yes. AC by XZ is also equal to 1. And BC by YZ is also equal to 1. So I wrote them separately. Here what I'll get? I'll get AB is equal to XY. What I'll get here? AC is equal to YZ. Here BC is equal to YZ. Got it? Now if you pay attention, AB is equal to XY, AC is equal to XZ. See? AB is equal to XY, AC is equal to XZ, and BC is equal to YZ. That is nothing but all sides of ABC are equal to all sides of XY, Z. That means by side, these triangles are congruent. Therefore, triangle ABC is congruent to triangle XYZ by side, congruency exists. Hence, quadratic demonstration. Then I have question number 5. D, E and F are respectively the midpoints of sides AB, BC and CA of triangle ABC. Find the ratios of the areas of triangle DEF and triangle ABC. So D, E and F are respectively the midpoints of AB, BC of triangle ABC. So I have a triangle ABC. A, B, C. Where D, E and F are midpoints of A, B, B, C and C. A, B, B, C and C. D, E and F. D, E and F are respectively the midpoints of sides A, B, B, C and C. Find the ratio of the areas D, E, F and triangle ABC. D, E, F. So you got triangle DEF. Now find the ratio of triangle DEF to the ratio of triangle ABC. Okay. What is given? A triangle ABC in which D, E and F are the midpoints of AB, BC and CA respectively. To prove, to find out we need to find the ratio. That means we need to find the ratio of the areas of triangle. That means area of DEF is to area of ABC. This is what you need to find. Area of DEF is to area of ABC. Solution. Now, see, first of all, what I'll do, let us take triangle, let us consider triangle DEF and ABC. First, just do one thing. Since D and F, write them like this, since D and F are the midpoints of AB and CA, AB and CA respectively. It's given that D and F are the midpoints of these sides. So, you know, you have read or you have learnt in your previous classes that a line segment joining the midpoints of two sides of a triangle is parallel to third side and it is half of it. This is a midpoint term which you have learnt in previous class. So I can say In that case, so D and F are the midpoints. So DF is a line segment joining these midpoints. So it must be parallel to BC and it's half of it. Therefore, alright, which implies that DF is parallel to BC and DF is equal to half of BC. You got it? And half of BC is nothing but BE, as E is the midpoint. BC. You got this one? The reason for this whole stuff is MPT, midpoint term. Just write like this. DF is parallel to BC and DF is equal to half of BC. Half of BC is BE. So in short, DF is equal to BE. The reason for this is as E is midpoint of BC. Got it? Now the whole reason is MPT. That's midpoint. You got it? So DF is parallel to BC and DF is equal to DF is parallel to BE and DF BE implies DF is parallel to, when it's parallel to BC, that means it's parallel to BE as well. Let me repeat this. From midpoint term, what you got, DF is parallel to BC. Got it? And DF is equal to half of BC. This is a midpoint term. Now, when DF is parallel to BC, DF is parallel to BE because it's the cutoff of the same line segment. So, when DF is parallel to BC, DF is parallel to BE. Similarly, when DF is equal to 1 by half of BC, that means DF is equal to BE because half of BC is BE as E is the midpoint of BC. So you got DF is parallel to BE and DF is equal to BE. DF is parallel to BE, DF is equal to BE. In that case, you got BEFG is a parallelogram. Therefore, BEFG is a parallelogram. Now this is a parallelogram because opposite pair is parallel and equal. Okay. Now when BEFG is a parallelogram, I can say then I can say this angle is equal to this angle. So then angle DFE, angle DFE is equal to angle B. DFE is equal to angle B. The reason for this is opposite angles of a parallelogram. Opposite angles of a parallelogram. Okay. Similarly, you can do the same thing for DF is parallel to EC, DF is half of EC, then you get ECFD is a parallelogram, then you can say this angle. First I got this angle is equal to this angle, then I'll get this angle is equal to this angle, again same reason. Similarly, angle FDE is equal to angle C. This is the same reason I can write for parallelogram ECFD. You got this thing? Okay. Now consider triangle. Consider triangle DEF DEF and triangle ABC. Consider these two triangles. You have like this, D, E, F, and you have the bigger one, A, B, C. These are the two triangles, DEF and ABC. DEF, ABC. Okay. Why I am considering in this form? Because I need to prove the area of this triangle is to, I need to find the area of this triangle is to this triangle, because it will make difference as far as similarity is concerned. We have already told you that. Now see, here what you observe in these two triangles, from this and this, angle DFE, angle DFE, so this angle is equal to angle B, so this angle. You got that one? This angle is equal, so I'll consider DEF and ACB, because the next one is, yes, let me consider DEF and ACB. ACB, write down like this. ABC you can write, but write down ACB, because DFE is equal to angle B. In order to get the corresponding angles, DFE, triangle ACB is ABC. There is no doubt in that. But the problem arises when you consider the corresponding angle. So corresponding angle for F is B, because it's equal. DFE is equal to B, DFE is equal to B. I wrote it here, so it will make no difference. ACB, ABC, that's the same thing. So our angle DFE is equal to angle B, then FDE, FDE. So go like this, ABC. Now FDE is equal to angle C. FDE is this angle. This is equal to angle C. Now you have corresponding angles. But see, it will make no difference, because I consider triangle DEF and ABC. Why I wrote like this ABC, not ABC in the usual form? Because my corresponding angles are DFE and angle B. DFE, so this angle must correspond to this angle, so I wrote B here. The next one, FDE, this angle must correspond to this angle, so I wrote C here, because FDE is equal to C. Hope you understand that. Angle F is equal to angle B and angle B is equal to angle C in this case. Now consider these two triangles, so write down, since angle DFE here, angle F or angle DFE is equal to angle B, and angle FDE is equal to angle C. Wherefrom you got these two? Prove it all. Prove it all. Therefore what I got? Triangle DEF. Yes, there will arise a problem, because here you have to write DEF is similar to CAB. Yes, DEF is similar to triangle CAB. Here you cannot say ABC, because D must correspond to C, E must correspond to A, and F must correspond to B. See what I'll just do. Now triangle DEF is similar to triangle CAB. There is no problem at all by angle similarity criterion. Then ratio into similarity theorem. What I'll get? Area of this triangle divided by area of this triangle is ratio of the square of one of the corresponding sides. So I took EF by AB whole square. No problem. Theorem 6.6. Then this side same. EF same. I replace AB. I replace it AB by twice EF. Why? Because if you see here, EF is half of AB. Midpoint term again because E and F are midpoints. So EF is half of AB. EF is half of AB. That means AB is equal to twice EF. EF is half of AB. AB is equal to twice EF. So AB is equal to twice EF. I wrote it like this. You got it? Now EF and EF gets cancelled. So what I have? 1 by 2 whole square. That is 1 by 4. So required ratio is 1:4. Therefore, area of DEF is to area of, now CAB, area of CAB is equal to area of ABC. There is no problem in that. CAB is same as ABC. The problem arises only in case of similarity. Now area of ABC is area of CAB. So I can replace now area of CAB by area of AB. See, that is nothing but 1:4. That's what I say. Kindly make a note. Hope you understand that. See you next time. May Allah subhanahu wa ta'ala bless you all. Assalamu alaikum wa rahmatullahi wa barakatuh.